For the last several months, I have been working on something new. I believe that my new open source project can help all of us make our code more beautiful and more efficient. The name of my project is Agile Data, although I'm open for a suggestion for a better name. Our application code is based on layers. The low-level code is responsible for things such as fetching or storing data. The mid-level code manipulates the data according to business rules. And the top-level code is responsible for presentation of data. Agile Data helps deal with the business and the persistence logic of your application. Apart from a few exceptions like Doctrine and Propel, the majority of MVC PHP frameworks today are focused on the presentation of your app, while giving you very basic tools for business logic building and database interaction. I have designed my framework so that you can use it inside your favorite MVC framework or application, adopt it into your workflows, test suites, API implementation, command line tools, or even cron jobs. And instead of just a lightweight ORM or query builder, Agile Data is a very powerful framework that can solve virtually any use case with incredible efficiency. My further presentation will focus around the following core features, which I will explain in just a moment. But to help you understand how Agile Toolkit works, we'll have to look at the specific scenario. Imagine that you're a developer working along with a team on building online accounting application. It will be used by third-party users who could register and then enter their own suppliers, clients, as well as their invoices and payments into your system. The object structure I have on the slide is really very clear. However, wait until you see the database storage. It all starts pretty nice with the first two tables, user and the system, which relate nicely to each other. However, as we look deeper inside the database schema, you start to see some differences. Whoever was designing this database, he decided that having two separate tables for client and supplier is inefficient. Instead, they will put them on the same table and I'm going to call them contact. Additionally, he figured that the user and the contact both have the contact information, which can probably be stored inside one same table, just to avoid duplication. The patterns like that are called data normalization, when you group the data inside the similar looked table. And it's just the extension of the do not repeat yourself principle. If you look inside the invoices and payments architecture, you will see yet another technique that is often used by the SQL engineers. It is called disjoint subtypes. And in here, invoice and payment both are presented by three tables. Whenever you need to select an invoice, you have to join it with the document table, and the same goes for the payment. So with ever-increasing complexity of our database schema, how can we map it under the very simple and very understandable entities? And this is exactly what Agile Data does for your business logic. It allows you to control the complex behaviors inside your database by using a simple models, just like this. Let's take a look at the presentation code. You might say, well, it does look like any other ORM, like Propel or Laravel's ORM. But what you have to understand is that entities like clients and invoices, they actually map into all these database patterns I was showing you, and it happens transparently. At this point, let me ask you a question. Should the rest of your developer teams and the rest of your application code be concerned about intricacies of your database schema? I'm pretty sure they shouldn't. And that's the beauty of Agile data. It allows you to hide the complexity of the persistence, such as SQL in this case, behind a very simple API. This is how it looks like. This is how it looks to load a client, load a system, load a client, and then add a couple of invoices. Very simple and clean code. So to give you a summary, Agile data implements a bi-directional mapping between your database schema and your business logic in a very new and intuitive way. It handles joins, both strong and weak, forward and reverse joins, and it can even import models as the joins. It handles fields. You can rename fields in a database without affecting your business logic. You can map types, map names, and you can define action-based hooks, such as before save, after save. Agile data supports relations. You can traverse relations using has one or has many relations. It also supports contained data. It probably doesn't make sense for SQL, but if you're using API or NoSQL as your data source, which is entirely possible with Agile data, some of them use hierarchical structures to to embed different types of records. And Agile data supports that as well. Cross-database relations, as well as you have very powerful expression engines, which can be either database agnostic, or can be something like PHP callbacks, or can be something like a SQL expression, and you're entirely in control over all that. During the demonstration, I will show you how we can use our complicated schema like this one and make it as simple to use as the code over here for the rest of my team members, other developers, and as well for myself. So to start things off, I'd like bring my SQL workbench over here, just to show you all the tables that are currently in the database. This is SQL Pro as well. It's pretty much empty except for the countries. Everything else is not over here. And I will also be using a set of classes that I have prepared over here, as well as a very, very simple file called demo.php. So let's look at the demo first. I'll comment these two. So we include autoload. We create a persistence to my database, and then we will launch interactive shell. So I can write a couple of commands, show you how it works. Also notice this one. So the dumper over here, that means every query which the library is going to execute will be also shown on the screen. Okay, now let's start with the simplest model. It probably is going to be country. Right? So the country is really simple. You have seen it in many other frameworks before. Table name over here, and then field name is defined over here. And so I'm launching my demo, and this country, which I'm going to call shortly as S. Country. There we go. So this actually didn't execute anything yet. So I just created an object called C, and if I want to see the data inside a database, I will have to execute something like export. So what export does, it fetches all the records from the database using this query, select from country, and show it to me. The other option I have is to specifically load the record. I go load, let's say 3. Okay, and load that one, and you see that the query now modified. Select where ID equals 3. Okay, and now I can do get. So it shows me that the current is Ireland. I can change the name of it. Let's call it Iceland. And when I'm saving, keeps showing me output. When I'm saving, it does update country, set name Iceland, where ID is this. So everything is very clear, as you probably have seen in many other ORM engines. Now let's look at what actually is exciting. And the next table I will show you is called user. Let's look at the design for the user model, which is stored in this class over here. Now this looks a little bit more complex. There are 2 native fields, username and email. And then if you look at the schema, it actually has a reference to contact ID, this one over here. And what we're doing is that we're saying the user cannot really exist without contact information. So let's create a join between the user and the contact info, and we'll use contact info ID field as the default joining between the both. And after we have defined the join, we're importing 3 fields from this join. So we're saying this field, 3 fields coming from contact info, and will become a native field inside the user model. Also, we're defining the relationship between contact info and country over here. So the contact information has a country field, and we're also pulling a field called name, which will appear as a country inside our model user. So to show you how this works, I'm going to create and when I call you export, you will see the query. There are no any users in the database just yet. We're going to add them pretty soon, but you'll see that actually creates a join and pull information from all over the place. So in order to add a new one, I'll do u insert, and in here I'll specify username. My username will name this be John, and I'll try to, if I can, create records with just this. And I'm getting this error, so it says unable to execute insert query. That's you'll notice that the query, the error is coming from ADK data, and it doesn't tell us much about the reason why it failed to load. So the thing about Agile data is that it has its own query exception class, and it contains a little bit more information about the query. So I will try to catch this exception like this, indicate an exception. Okay, should do a catch. And it has a capability of showing us colorful information about what has happened. So I'm just going to execute that. Right, now this is much more comprehensive exception, and let's just go over this to see what's going on. That's our exception text like before. There are additional information inside the exception, which contains a query, which we try to execute. So insert into user, ID, username, and email. Which model was it that tried to execute? And over here you see the actual PDO exception, which says there is a constraint violation. The column country ID cannot be null. So we had to specify country ID. And over here, you see it does highlight in red the line which is most probably caused this error, and it was indeed the line that we wrote. So something was wrong with this line. So let's say country ID equals 2. And now I should have one user. So I have John with country ID 2, and it automatically pulls Latvia as a name of the country. Now I wanted to show you one really interesting trick. And when we're creating a new user, let's say I want this user to be from, let's look at the countries again, from specific countries, but I don't know the ID of the country. So on the country, B. Okay, so these are the countries. Let me actually quickly add a new one. We'll call it India. Okay, now we have India as well, but let's say we want to add a new user now. Username will be Rakesh, but I don't know the ID of India, and I also don't want to create additional query. So what I will actually do, I will take the country, okay, I'll do it clean. So new model country DB. I will set the condition to on name to India, and then I'll use action to fetch an ID field like this. Okay, so let's look what's going on in here. So it's just like the same query like before, but instead of the actual ID, I'm specifying another model, and I'm generating, well, I'm setting the condition in this model, so it won't have all the records, but it will just have one record, and I'm specifying action to fetch only the ID field from that record. Let's see how it works. So that's really fine. Let's look at the actual query. So there were two queries. The first was inserting into contact information, and the second into the user. And the country ID in the first one was equal to this select over here. So selected ID from country where name equals India. So if we're building an import that, it's incredibly handy to have ability to look up things like that. And let's say if I mistyped country like that, it actually doesn't execute the query, so nothing else will happen. Let me export the users again. I have two users, from John from Latvia and Rakesh from India. Okay, so with that, I would like to move on and look at this relationship between the user and the system, and let's make it work, and let's see what we can do about that. So from here, if you remember user, there were no relationship between the user and the system. The system actually is also quite simple. The system actually does have a relationship to user, but the user doesn't have a relationship to the system, and it's absolutely fine, because these relationships are logical. You can add them as you need. So right now we have a user over here, and I'm just going to create this relation relationship between the user. And now that I have it, I can do u. So s equals u ref system. Yeah, right. So okay, let's say the user has logged in. What we have to do is perform a load by, because the user is not currently loaded, so it's not loaded. We have to do a load by username Rakesh. And now if I say loaded, it says true. If I do user get, it gives me information about Rakesh. And if I look at the systems, it will show me all the systems that where user ID equals 11, which is the ID of the Rakesh. And it doesn't have any system right now. So I will go ahead and create the system. I'm going to call it Microsoft. I'm going to call it Microsoft. Okay, cool. Now let's look at the query, which was generated and says insert into system. And you see it automatically specified the user ID as well. Right, so if I now do export, there is this user Microsoft with ID 11. Okay, and next I would like to, let me look at the users. And this time, let's say the Rakesh went away, and the new user came back, and now it's John. Yeah, so we have loaded John, and let's see what systems John has, and then none. Right, so it's a very good, safe way to add systems like this to Google. Okay, now there is Google, and if I create as like a system separate system, and I export that, then we have both. But if we go through a user, there's only one. So that's one of the very important parts of Agile data is ability to imply conditions as you traverse references. The next model I'd like to look at will be implementing what we generally call contact. And there are two types of contacts, one of them being supplier and another being a client. So if we look at the client, it just contact with a condition type equals client, and the same for supplier. So all the logic actually sits inside the client. Sorry, contact. That's the contact. So the name is of the table is contact. It has a name. There is a type, which can be either client or supplier, and there is a status, either active or suspended. It also relates to system ID, and it has many invoices and many payments. So let's go back to console now. We have this system Google. Let's do this. So we'll be working with Google. Is it loaded? No, it's not loaded. So I'm gonna try and load any, which will just load the first system available, and it's going to be Google. Okay, so from here we'd like to look at so we have already a relationship, but you see the relationship is not with the contact. Instead, the relationship is done with either client or supplier. So, okay. Let's see if there are any clients. Okay, we don't have any. insert. I just do this, and there we go. So we managed to insert a new record for the client, plumbing. So the type automatically set to client. Okay, the system is pulled up. It's all good. The country is set. And let's add another client. This one will be system restore from the country to, and testing. Okay, so we added a couple. Now, my next, what I wanted to show you next is ability to change multiple records at the same time. So, first of all, if you remember that, whenever referencing the client, I already have a scope which limits me to a specific system, and you can see it over here. So where system ID is 11, it's 14. It's always enforced, and it doesn't stop me from adding more conditions. So I could do add condition saying 3b equals 2, right? 3b equals 2. Also, what I can do is to say country equals Latvia. Works just as great. Let's look how it appears in the query. And select name from the country where ID equals Latvia. So this is actually not using having, but it used where, but it was intelligent enough to understand that this is not a regular field, but it's a subquery, and it conditioned the subquery. So that's actually the faster way to do it, and then use having. Anyway, we have two clients over here with a condition. What we want to do is perform an action on those two clients. It's going to be update action. I will change status to say inactive, and I'm going to execute that. And final drop the country. Okay. It's because it's not the condition is set on the join table and doesn't work yet. It will be fixed in the final version. So anyway, what I did over here is I changed all the contacts to set status to inactive, where my conditions are met. I will just have my condition. And now if I will be doing the export, you'll see that all these are inactive. Okay, it's good enough. As my next demo, I will be looking inside the documents, right? So okay, let's use okay, let's use plumbing. Let's client mode 9. Okay, that's our plumbing, and let's look at a couple of things for this client. So first of all, client, if you remember, the client is the sends from contact, and the contact has many invoices, has many payments. Let's look at the invoice. So when we add an invoice, wouldn't be an invoice yet, but I can insert one, and I have to specify. Okay, so invoice extends from the document. So yeah, so first of all, let's look at the database. This structure with two tables like that is one of my favorite structures in the SQL. It's called these join subtypes, and you define one main table, and then there are two which extends depending on the value of type. So if the document type is invoice, then it will be joined with invoice, and you get the additional fields from invoice. So let's look how that is implemented. Again, like with the contact, we have a base model called document, and it has ref_no date type. And here payment, and it does relate back to the contact, which, if you remember correctly, could be either supplier or the system. There's also a field called isArchived. Okay, now if I look inside the invoice, it does create a join and brings two fields from the join called purchase and shipping. Also there's a condition on the type. So let's add a new invoice into the database. Insert, and we have to specify that was a cost of the purchase, and the shipping. Purchase was 10 and shipping was 5. Okay, so what's cool about this is that there's a column called total, which is now 15, and the way how it's defined is it is defined as expression where it adds purchase with the shipping. Right, so I just use that, and if we're looking inside the query, that's our total, and this is how it's defined. So both columns are actually coming from the join table from invoice, and it automatically prefixes them and adds, and also now pass them escapes. It's pretty intelligent. And then here, the purchase I'm using, you just have to match with the name of the database, the model field. So that's, again, that's mapping. Let's look at the, let's insert another one. Shipping. Okay, so we have two records now. What I wanted to show, again, going back to actions, is another action called fix. It allows us to perform operations such as sum on a specific field, and let's do a sum of purchase. If I execute that, actions. So if I execute that, it gives me back a query, and with getDebug query, I can actually see what the query will look like before executing it. So it will select sum of purchase from document. I've joined invoice, and all the conditions are here. So the contact ID is 9. Okay. And if I do get 1, it gives me 40. Now what I wanted to show you here, remember we had S, which was the system. If I do ref with this client, yeah. So if I take the system, if I traverse into the clients, and then without loading any single client, I traverse into invoices and execute the action, let's look how the query will look now. So still sum, but contact ID now is in select contact, from contact, left join contact info, blah 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 blah, and the system ID is 14. Let's see who gave us. Yeah, it still gives us the correct information. information. So what is cool about this one? So we managed to look at the total of all the invoices of all the clients within this current system, and it worked beautifully. Right, so no extra selects. I was able to express myself using double traversal, and this is what's called dataset to dataset traversal. So I had multiple records. I didn't load a specific one. I could load it over here, but I didn't. And I went into the invoices, and it still worked. So that's one of the amazing parts of Agile data. Let me show you another one. Let's do a sum of total. And it now says 25. But the calculation is much more complex. So the sum is not of a single field, but actually uses a query over here, expression, which consists of two columns, purchase and shipping. Again, it automatically figured out what needs to be there, and it just works. See, I need this one. Okay. So that's okay. That's all the clients of my system. Yeah, we have 3 clients. Okay, yeah, let's look here. So now that I have all the clients, I have a relationship into the invoices. I want to create an aggregate function. So that just gives me the object, the relationship object. So expressive and so on. Yeah, so that's a field many relation, and I cannot field purchases sum, and I'll use field total. Perfect. And now I'm going to do export. You'll see purchases over here. Yes, okay. So these guys didn't have any invoices, but this guy, plumbing, it has invoices for the total of 45. Let me also add payment. Yeah, I want to see query, so it's still same one query. Payment. We'll go into the payments. Let's just double check the field. Field in payment is called amount. Okay, now I have purchases and payments over here, right? Okay. So, okay, I'm gonna load plumbing, and in payment, I'm going to insert with amount. Let's say he paid 30, right? Now let's see what's inside here. Okay, so it created the payment. You should actually set the date. It also did for the invoices as well. All the correct dates over here. Next, let's go to the list of clients. Yeah, okay, so the payments is no, because the record is still in memory. If I do reload, see that it's now being calculated. It's now set correctly. What happened during the reload? It executed the new query. Right? So the query grows bigger, but is still very, very specific to what I need. Okay? And now, well, you might say the query grows bigger and bigger. It might be a problem. Well, in Agile data, there is a way. Let's say I only want name, type, purchases and payments. See if it works. There you go. Okay, going back to the query. It selected name, type, purchases. There you go, purchases and payments. It also pulled the ID and the system ID because this is important fields. But that's it. And now when I'm pulling get, I only have access to the fields which I said are important to me. Let's see only name and type. Okay, if I'm loading this now, I don't know, I don't need those statistical fields maybe at this point. So it doesn't load them. And query is back short again. So that was the demo of how Agile data actually performs in practice. My next section is about datasets and actions. And this is what fundamentally distinguishes Agile data from the variety of so many other ORMs out there. So to start, let's look at one of our tables called contacts. And whoever designed SQL schema, he decided he wants to keep both clients and suppliers in this database, in this table. Also, you see that the records belonging to different systems are actually stored in here. When we write code like that, you'll see that there are some conditions applied, and our dataset is narrowed to only 2 records. If you or any other developer tries to load record outside of the dataset, he gets failure. That's a fail-safe security mechanism built into Agile data to keep your data consistency. The other fundamental concept that innovated by Agile data is called actions. Whenever you have dataset, you can execute an action and it will affect all the records in this dataset. So in this example, I'm executing an update action which will change field status to active. And the beauty of this is that instead of iterating through those actions and changing them one by one and then saving them back into the database, this action is executed on inside SQL because SQL does support multi-record updates as well as many other NoSQL databases today. So in this scenario, there are 2 conditions using system ID and type. However, you can traverse from one dataset into another dataset. For this specific model, will contain only 2 records, which corresponds to our suppliers. And again, you can execute actions on in here as well. Here I'm showing you another type of action, which is aggregate action. It executes the sum across our dataset and will respond with the sum of all of our IDs. I did choose IDs because there are no other columns so it doesn't mean giving back 4. To summarize, the capabilities of datasets and actions, they are here for your application security, to prevent from accessing records outside of your dataset accidentally, and also to enforce that when you add new records, they are part of your dataset. Datasets are amazing for traversing relations because it costs you no extra queries. It allows you to perform deep traversal. Agile Data also features a pretty interesting extension system, so you can build new type of relations. Datasets also work for NoSQL databases. Things like sum, max, count, and so on will be emulated if your database engine doesn't support it. Whenever you have to cross from one database into another, Agile Data automatically figures it out and it executes the query, gets a list of IDs, and then use this list of IDs inside another database because that's the only way. However, if you are on the same database, then it will use expressions and will just substitute expressions. Performance. So when you use ORM, there are a number of performance issues that can slow down your system. If you think in terms of dataset and actions, you can avoid hitting any of those problems. Actions always make use of database features if they are available. And then whenever a new database comes out, or maybe existing NoSQL database adds a new feature, their respective driver could be improved to support this feature and execute a couple of these actions on the server side. So think about aggregate framework inside MongoDB. It's just built for actions. The last and a pretty fundamental feature of Agile Data is business model aggregation. And the reason why it is not a regular aggregation but a business model is because you build aggregate models on top of your existing models. And all the complexity, all the joins, all the expressions, it is all correctly embedded inside. You don't have to worry about any of that. So let's look how can we use aggregations. So in our schema we have clients, and the client has invoices and payments. We can combine those using a union inside a separate model, which will be called client statement. And the client statement will contain records for both invoices and payments, showing you the history for a specific client. And it will behave just as a regular model, except that you won't be able to edit the records and set them back. And then finally, you can use a combination of the client model and the client statement model to create a new model called debtors. And this will show you all the clients who owe you money at this point. So you have to perform a join, you'll have to do some aggregation, and you have to do a condition saying that you're only interested in clients whose balance is below 0, and this is a list of clients you need to chase your money from. So aggregation and reports, they offer you an additional layer of how you can utilize your nicely defined models. So first thing you can do is create derived models. And while the source of regular model is typically a table inside your SQL database, for derived models, the source is another model. Model can import or aggregate fields from the source model. And then finally, you can query some specific fields, which means even if you define hundreds of expressions inside a model, you can only select specific ones, so you're not wasting CPU or bandwidth. And finally, derived models can be nested. So the source of a derived model could be another derived model. Union is a special type of derived model because it derives from multiple models, and it can combine them, and it can figure out which fields to show and not to show. It handles joins, expression, and subselects transparently, and it does field mapping for you. Finally, there is also a good NoSQL support. You can do in-memory processing on aggregation, which is based around declarative logic and iterators. And you can define your own routines and make use of caching if you want. However, when it comes to performance, using derived models and unions are extremely efficient when it comes to SQL. It is all totally based on business models, so you're unlikely to make any mistakes, and it's much faster than stored procedures, both in terms of writing them, maintaining them, and execution. Aggregation is coming soon to Agile data. The rest of the features are already available as a part of Agile data beta version. So at this point, I'd like to ask you to give it a try. Agile Toolkit is pretty new, and I do need to hear your feedback. Try it in your project. If you like it, share it with your friends, with social media. It is absolutely free. It has MIT license, and you can use it inside your both personal and commercial projects. We also have a list of simple tasks if you want to get involved. You can just browse the list, and maybe there is something you can actually help us with. And finally, please do subscribe and follow us for any news. And if you consider using Agile data inside your commercial project, then my company is offering support, SLA support, as well as long-term version support. We can discuss additional custom features with you, including custom database drivers, as well as you get priority bug fixes.